This is chapter 8, question 22, winter 2006, question 22, yeah? This question is about the dissociation of sulfuric acid. Now, sulfuric acid is a very special acid because it is a diprotic acid. Now, what's diprotic acid? Diprotic acid means one acid molecule will dissociate and give you two hydrogen ions in total, right? So two hydrogen ions per molecule. So a diprotic acid. So look at the molecule of sulfuric acid, H2SO4. Okay, so there are two hydrogen here. So you can dissociate and give you two hydrogen ions. But you see, actually it is not a one-step process to give you two hydrogen ion. It's actually a two-step process. Okay, this is step 1, step 2. So first, the H2SO4 release only one hydrogen ion, give you a hydrogen sulfate ion, a conjugate base. Now this conjugate base can still further dissociate into another hydrogen ion, right? So two-step process. So in sulfuric acid, actually there are two acids. One is the H2SO4, the other one is the HSO4 minus hydrogen sulfate ion. Okay, so step number 1, if you look at the arrow, it is a full arrow going to the right hand side. Okay, what does this tell us? This one tells us that, okay, this H2SO4 is a strong acid. Okay, this is a strong acid. Complete dissociation. Okay, if I have 10 molecules of H2SO4 in the solution, all 10 will dissociate and give me 10 hydrogen ion. So that is what it means by complete dissociation. But HSO4 minus, the hydrogen sulfate ion, is a weak acid. So we no longer see full arrow, we see the double arrow. That means this is reversible. Okay, we get equilibrium in the solution. Equilibrium between this hydrogen sulfate ion, hydrogen ion, and sulfate ion. Okay, and this is not complete, yeah, because this is a weak acid. Okay, this arrow tells us this is not complete. Equilibrium. Okay, now I found online that the Kc to this, Kc to this step, is actually 1.02 times 10 to the power of -7. Very, very small equilibrium constant. That means only very little hydrogen sulfate dissociates and give us hydrogen ion and sulfate ions. Okay? Now, you have not learned this one yet because this Kc has a special name called acid dissociation constant because this is an acid. Okay, and you're going to learn this in A2, and you're going to learn how to use calculation to find the concentration of hydrogen ion and also the base, okay, in this solution. So I found it already. The concentration of hydrogen ion, okay, in this solution is actually 3.19 times 10 to the power of -4. Okay, which is very small, okay, very low. Now, before I go to the explanation, I want to build a table first. Okay, build a table so that we see later in the solution. Okay, in the solution, what are the concentration of all these different species? All right. Okay, then list down first. H2SO4. I have hydrogen ion. Okay, I have hydrogen sulfate ion. Okay, hydrogen sulfate ion again. We're going to just put everything under the same category, so don't rewrite, don't repeat. Okay, H plus again, and then I have sulfate ion, yep. Okay, so now, which statements are true for 1 mole per decimeter cube of sulfuric acid? So in 1 decimeter cube, there's 1 mole of sulfuric acid. So let's just assume all this solution is 1 decimeter cube. Okay, right? In 1 decimeter cube of solution, okay, I have 1 mole. So here, 1 mole. That means I start with 1 mole of this. Right, can follow? So at the beginning, of course, I have 0 here. Okay, 0 before dissociation. After dissociation, because this is a complete dissociation, all of these will turn into hydrogen ion and hydrogen sulfate ion. So later, okay, no more this one, because all dissociated. Now I have 1 mole of hydrogen ion in the solution, 1 mole of hydrogen sulfate ion in the solution. Okay, can okay, so 1 mole, 1 mole. Right, this one no more. Okay, because all gone, all dissociated. All right, now I have this 1 mole hydrogen sulfate ion which will further dissociate. So I bring this down to here, 1 mole. Okay, right? Now I'm going to erase this a bit because it's covering. Oh, sorry. It's too big. Okay, it's okay. I'll rewrite that thing. Okay, now see this 1 mole. Okay, I said I did some calculation earlier. Okay, so at the end, this 1 mole of hydrogen sulfate ion will dissociate and give us 3.19 times 10 to the power negative 4 mole of hydrogen ion. Right, smaller. Okay, so it's 3.19 times 10 to the power of negative 4. Right, 1 hydrogen sulfate ion will dissociate and give us 1 H plus 1 sulfate ion. So this one also same concentration, same amount. Okay, so yeah, you see, now I have to add 3.19 times 10 to the power negative 4 here for hydrogen ion, because they are all in the same solution, don't forget. Right, everything in the same solution. Okay, so I need to add now another 3.19 times 10 to the power of negative 4. So all together, let me do the calculation. Okay, actually it's very small. 1.000319. Okay, all together, one point zero zero 0319. Okay, now let's look at hydrogen sulfate ion. Since it releases this much of H plus, so this much of hydrogen sulfate ion is dissociated. So here plus, just a plus, here will be minus. I should leave more space, but it's okay. Let's try to make it smaller. Yeah, I hope you can see. So I need to minus 3.19 times 10 to the power negative 4 here. Okay, so do the calculation. It is actually very close to 1 also. 0.1 minus 3.19 times 10 to the power negative 4, yeah? Okay, 0.999681. Okay. Then sulfate ion. Remember sulfate ion? Okay, is this one. Okay, because you didn't get sulfate ion from the earlier dissociation. Okay, you only get from dissociation of hydrogen sulfate ion. So at the end, this one is 3.19. Okay, so let me like just try to highlight the, right, I'll just highlight the final one. This, and this. For hydrogen ion, hydrogen sulfate ion, and sulfate ions. Okay, the number of mole in 1 decimeter cube solution. So these are also the concentrations. Okay, because all divide by 1. Okay, now let's look at all the statements. Number 1, concentration of hydrogen ions is high. This is concentration of hydrogen ion. Okay, is it high? Yes, it is already the highest among these 3 concentrations. So let's put a tick beside number 1. Number 1 is correct. Now number 2, concentration of sulfate ions is high. Now look at sulfate ion. It is actually the lowest among the 3. So number 2 is not correct. 10 to the power of negative 4 is very low, the concentration. Now let's look at number 3. They say the concentration of hydrogen sulfate ion and concentration of sulfate ion should be the same, equal, right? So let's look at these two. Concentration of hydrogen sulfate ion, concentration of sulfate ion. Are they the same? No, not the same. Some close to 1. Okay, this is very low. 3.19 times 10 to the power negative 4. So this is not correct. So the answer to this question is D. Okay, only one is correct.